Alrighty guys, welcome to 11.6, events involving not and or, and then it says odds. So, find the probability that an event will not occur, okay? The second objective, find the probability of one event or a second event occurring. And then finally, understand and use odds. Okay, so simple enough. An event, so probably an event will not occur. This is probably going to be, key terms complement. Okay, that's what I figured. So it's going to be about the idea of, quick example. If I told you that the probability that it will rain tomorrow, let's say the probability that it would rain tomorrow. Oh my gosh, my handwriting is terrible. So the probability, and I make sure I want to explain myself. If I say P parenthesis, that's going to be the probability of, and then I put what I'm going to want the probability of, right? That it would rain tomorrow. Okay, and let's say the probability is, let's say 30%. That means that the probability it will not rain tomorrow. So the probability it will not rain would be 70%, right? And the reason why is because these two are complement of each other. The opposite of one is the other, so they add up to 100% or 1. That's the idea of complement. So complement means the probability of A and the probability of not A equals to 1. Let me put this a little bit neater. Not A equals to 1. That's what it means. It's just they complement each other for a total probability. So if the probability of raining is 30%, then the probability of not raining must be 70%. That's the idea of a complement. So let's see. Okay, yeah, that's what I said. And then solving for, okay, so let's see. Sometimes, and this is true in probability, sometimes to find something that you want, sometimes you're going to use the complement of it to figure it out. So for example, if someone told me, I wonder if the probability is not going to rain tomorrow. I said, well, let me see. It's going to rain, 30% chance of raining tomorrow. So then, and then you just do 1 minus 30%, right? It's pretty simple. That's the idea. So let's continue. So for example, it says here, if you roll a single die, a single 6-sided die, find the probability of not getting a 5. Well, you could do this. You can say, oh, I have the numbers here. So you can say not a 5 is 1, 2, 3, 4, 1, 2, 3, 4, 5. There's 5 numbers out of 6 that are not 5, so the answer is 5 out of 6. Or you could have done it this way. You could have done it instead, say, okay, well, let me think about this. The probability of getting a 5 is 1 out of 6. And so that means that not 5 is going to be the opposite. So 1 minus that probability would be the probability of getting not 5. That makes sense? So that'd be 5 out of 6. Same idea. Okay? So that's how you would do it if you were doing it with complements. And sometimes complements are the only way to do it. You couldn't, even if you wanted to, you couldn't do it by counting out the favorable outcomes. So you have to, the non-favorable outcomes, divide that by the total, and then that's the probability that you're going to subtract from 1. Okay? So let's look at the next example. Suppose a jar has 4 white marbles and 3 red marbles. Find a probability of not selecting a red marble. So if selecting a red marble is 3 out of 7, then you do 1 minus that to get the probability of not red. Okay? Which is 4 out of 7. Some people are going to be like, oh, wait a second. It's the same thing as getting the probability of being white. Yes, the probability of being a white marble is 4 out of 7, but the point is you can subtract 1 minus the probability of red to get not red. Okay? Let's look at this one. You are dealt 1 card from the standard 52 card deck. Find the probability that you are not dealt a diamond. Okay, so I see 13. So that means I was going to say, oh, there's 12 diamonds. There's 13 diamonds. I'm dumb. So the 13 out of 52 diamonds, so the probability of not being a diamond would be 1 minus 13 out of 52 because it's obviously the rest, right? So they did that and they got 39 out of 52 or 75% chance. So if you wanted to know, I don't want a diamond, we have a 75% chance of not getting one. So here we go. If you were dealt 1 card from a standard deck of cards, find the probability that it's not an ace. Well, I know there's 4 aces, right? Yeah, 4 aces out of 52. So the probability of not getting an ace would be 1 minus that because again, it's going to be the complement of it. So complements add up to 1. So if you subtract from 1, you get the other one. Okay. So what is this? 1 is 52 over 52. And then minus 4 over 52. That's going to be 48 out of 52. Right? So I won't simplify. I'll leave it like that. So can I simplify? Yes. by what? I can divide that by 2, obviously by 4. By 4. I think I can do both by 4. Let me just do that. So that's 1, 2. And this is 1, 3. Yeah. So it's 12 out of 13. Okay. All right. So here we go. Next lesson. Okay. So this is the probability of one event or a second event. Let me explain what this means. So suppose I was going to tell you, okay, if you roll a die and you roll a 1 or an even number, you'll win or something. So that's two different ways of winning, two different scenarios that are not necessarily related that will help me win. So if I want the total probability of an or event, so again, let's pretend I'm playing a game. I want to just make sure I spell it out. And the rules is if you roll a 1 or an even number, you win. So if I get a 1, I win, and an even number, 2, 4, 6, I win. So the probability of getting a 1 is 1 out of 6, right? The probability of getting even is 3 out of 6. So I either get this or this, which means if I add them up, I get 4 possible out of 6 ways of winning. Let's see, 1, 2, 3, 4. We guess it's correct. So if I land on a 1 or even I win, I can add the probabilities and win. Now this is assuming that the two events I'm describing are mutually exclusive, okay? Or some other books will call it disjoint. That just means that it's not possible for those two events to occur simultaneously. So if I say, for example, you can win if you land on 4 or any number bigger than 3 or something. Well, then there's overlap there, right? Landing on 4 or any number bigger than 3. Well, bigger than 3 is including 4, so I don't have to worry about the 4 part. You know what I mean? That's not mutually exclusive. That's not disjoint. So if they're disjoint, you can just add the probabilities and you get the total probability, like the probability of getting a 1 or probability of getting an even number, okay? Now, sometimes there's complete overlap, sometimes there's very little overlap, but there could be overlap, and we call that not mutually exclusive, okay? And then we can add them up to get ORs. So it's going to be a little bit different for non-mutually exclusive probabilities. We'll see if they give an example, and we'll cover it. So, again, two events that can never occur at the same time are called mutually exclusive. For example, the probability of landing on an even number and the probability of landing on a 1 are mutually exclusive. There's no way you're going to have an even number and a 1 at the same time. They're not the same. They're completely different events. So those probabilities can never happen at once. So suppose you select a random deck from a card. Let A be the event selecting an ace and B the event selecting the king. So those are exclusive events. It's never possible to satisfy both of those at the same time, right? They're always separated. So if you want to find the probability of two events, of a one event occurring, but it has two possible options, like a king or an ace, then that's going to be just adding the probability of a king and the probability of an ace. Simple as that. Now another example. Suppose, and let's actually do that. I don't see the work here, but let's see. So the probability of getting an ace is 4 out of 52, and the probability of getting a king is also 4 out of 52. So the probability of getting a king or an ace would be 8 out of 52. It's really simple. Okay. Suppose you have a jar with 4 white marbles, 3 red marbles, 3 blue marbles. Find the probability of selecting a white or red marble. Well, what's the probability of getting a white marble? Let's see. There's 4 out of, let me see how many there are. There's 4, 7, there's 10 marbles. So you have 4 out of 10 marbles that are white. And then you have red. How many? There's 3 out of red marbles that are in that jar. So what's the probability of getting white or red? You add them up. You have 7 out of 10 marbles that are either white or red. So it's a single event, but it has two different ways of winning. Think of it that way. Now, here it is. So it is possible to find a probability of two events where they are not mutually exclusive. For example, if I say the probability of getting, let's say, a king or a heart. Well, king has a king of hearts, so you're not going to count the king twice there, right? You're not going to count the king's heart a second time. So that's a good example. So let's see. Suppose you have a selected card from random, whatever, find a probability that's a spade or a king. Okay. So there are 4 kings. We'll do that first. And there are 13 spades. Correct? But there's one king that's a spade. So you're not going to count them twice. You're not going to count that king here and here. Remember, if you have the 4 kings here, and then you have all the 13 cards, right? The king of spades will be here and here. You're not going to count it twice, so you have to subtract one out of them. So subtract one of them. Like either subtract this one or that one. But one of them has to go away. So then you end up just basically saying, I'm going to subtract the overlap, which is 1 out of 52. So that's going to give us 4 plus 3 is 17, minus 1 is 16 out of 52. And that's the probability of getting a spade or a king. Now some people can say, well, what if I just did this? What if I just, wrote all the cards and say, okay, here's king of hearts. My gosh, my handwriting. My hearts, the king of diamond, the king of clubs, and then the king of spades, right? And then I have all the spades here from 2, 3, all the way to it gets to J, king, or queen, sorry, king, and ace. Well, I can't use this one again, so I just erase it, and then I count. So I have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I counted something wrong. Let me do it again. Actually, I'm going to write the numbers quickly. So these are the spades. 2, 3, 4, 5, 6, 7, 8, 9, 10, J, queen. We're not going to put the king and ace. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because I already have that king here. So 12, 13, 14, 15, 16. So there's your 16 cards. Okay? Hopefully that made sense. So let's see. If you roll a single die, a single 6-sided die, what's the probability of getting a 4 or a 5? That's an exclusive event because 4 and 5 can't happen at the same time. So the probability of getting a 4 is 1 out of 6, correct? Probability of getting a 5 is 1 out of 6, and then you just add them. You're going to get 2 out of 6. That's it, which is 1/3 if you simplify. So let's see. You select a card at random from a standard 52 deck of cards. Find a probability of selecting a red or a red 2 or a black 3. Well, that's again, a red 2 is a very specific card, right? There's 2. There's diamond and hearts. So there's 2 out of 52 cards that are red. Red with the number 2. And then there's 2 cards that are black with the number 3 on it. But they don't overlap. You're not going to get a red 2, 3 black card mixed, right? They're completely separated. So that's a total of 4 possible cards out of the 52. Okay. Let's see. All right. That was interesting. Okay, they didn't have an example of not mutually exclusive. Okay, let's do the next one. The last objective. If I recall, I remember seeing 3. So let's see. Using odds. Odds, guys, in case you wonder, is a ratio of win to loss, really, or favorable to not favorable. So, example, let's say I have a way of winning, right? I have 3 ways of winning and 2 ways of losing. We're going to call that 3 to 2 odds, right? Because I have 3 ways of winning and have 2 ways of losing. It's not a probability. It's not saying the probability would be this. I have 3 and 5 chances of winning. This is a probability. Odds are always stacking against the number of wins compared to the number of losses. That's how it works. Okay? So here we go. If we know the probability of an event E, we can determine the odds in favor and odds against an event. So the probability of E and a probability of... Let me just get to the point. Let's do an example. So, you have a jar. It has 4 white marbles, 3 red marbles, 3 blue marbles. Find the odds of selecting a blue marble. Well, I have 3 blue marbles. Now, I'm not going to do probability. I'm not going to do 3 out of 10. That would be the probability. Don't do that. I'm not doing probability. Odds are going to be favorable outcomes, ratio, or you can put a fraction if you like. I see they have a fraction, but they usually have a column to unfavorable. Not total, the remainder. So, if 3 were blue and there's 10 total, then that means there's 7 left. So you have 3 to 7 odds. If you say 3 over 7, you can, I guess. That's what I have it here. No big deal. But it's usually written like that. Okay? 3 to 7 odds. It's just that simple. Favorable to not favorable. It's nothing to do with total. If you want probability, you add these two up and you're going to get the total. Then you say, okay, so it's 3 out of 10. That's a probability, not the odds. Odds is more about counting how many ways of winning and losing. So let's do the next one. Find the odds of against selecting a white. Okay, so it's against selecting a white marble. So if it's basically saying not white. So let me see, there's 4 whites, 3 reds, and so that's 4, 5, 6, 7, 8, 9. There's 10, okay, that's right. There's 10 marbles. If you want to go against it, that means instead of saying 4 to 6, we're going to actually say 6 to 4, because winning means not white. So it's backwards. You know what I mean? It's the same two numbers, but just backwards. So it's against white, meaning you don't want white. You want other colors to white. So this is my answer. And of course, you can simplify that. Those both divisible by 2. So you can say 3 to 2 odds of getting not white, right? And okay, here we go. So let's do 2 quick examples. Is that the last? Yeah, it's the last. All right, here we go. You're dealt 1 card from a 52 card deck. Find the odds in favor of getting a red queen. So there's 52 cards total. A red queen. There are 2 red queens, right? But then we're not going to do out of 52 cards because remember, we took those 2 queens out. How many are left? You have 50 cards left out of 52, right? So you have a 2 to 50 odds chance of getting it. So like basically it tells you have 2 ways of getting a queen and 50 ways of not getting a queen. That's what that is. That's for A. Okay, let's see how they did it. So there's 2, number unfavorable is 50, so the odds are 2 to 50. They can simplify that to, what is it, 1 to 25? Yeah, that's true. So that's the answer. Those are the odds. Let's see the part B. Find the odds against a red queen. So against is just the same thing but backwards, right? You want to say the probability of, or I'm sorry, the odds of not getting a red queen. So you have 25 ways of not getting a red queen and 1 way of getting it. So it's just the same thing backwards. So let's do the next one. A single die is rolled. Find the odds in favor of rolling a number greater than 2. So you have 1, 2, 3, 4, 5, 6. Greater than 2, there are 4 ways of getting greater than 2, right? In favor. So you have 4 ways of getting greater than 2, and you have 2 ways of not getting greater than 2. So you have 4 to 2 odds. You can divide both by 2 if you want. So you can technically have 2 to 1 odds. Okay. So your odds are in your favor, right? You have 2 to 1 odds. This translates to 2 out of 3 probability because you add them up to the total. So you have a 2/3 probability of getting that. Okay. So that's the idea. 2 ways to win, 1 way to lose. B. Rolling against a number greater than 2. So against means not greater than 2. So not greater than 2 means less than or equal to 2, right? So there are 2 ways of getting that and 4 ways of getting greater than 2. Or you can simplify it to 1 to 2 odds. You have 1 way of winning and 2 ways of losing. Okay? I hope that made sense. And I hope you guys are enjoying these videos. I think we have 1 more left before we're done. And then hopefully you guys are ready for a chapter 11 test. So, alrighty guys, see you soon.